So when we use buttons or push buttons or switches as input to an Arduino or other microcontroller, we might run into a problem called bouncing. And so I'd like to just really briefly talk about debouncing, or how we handle bouncing. And first of all, what it is and how we handle it. So debouncing switches or push buttons. So debouncing sounds kind of sad at the start. You know, you might think it's popping a bouncy castle or something terrible like that. But in fact, it's a very happy thing. It makes our switches work. So assuming that we come over here and have a couple of push buttons here. Here's the one that's probably in your kit. Here's a larger one just for demonstration purposes. And so when you press it, you just hear this big loud chunk. And so it sounds like the switch is being engaged, and then you take off the pressure and the switch sounds like it's being disengaged. Here's another kind of switch. There's really thousands of different kinds of switches and what they look like. This one here is not technically a push button. It's called a micro switch. It has 3 pins. One is normally open, one is normally closed, and then when you push the button, it basically does the reverse, or it closes the normally open one and vice versa. And so the actual little push button is just that little red bit right there. But it's also got this wheel on it, and so it's sort of meant for physical things to come in here and touch it, like in machines. Maybe you had a moving surface and whatnot, or something that kind of comes in this way and just kind of hits it somewhere. These are primarily used in machines, which is why we have a bunch of them in here. And so it's sort of the same deal. From our sort of macro level, we look at this and we're like, okay, the button's on, the button's off, the button's on, the button's off. And so that's why debouncing, or rather that's why bouncing itself is such a mysterious thing when you first encounter it. And so what is bouncing? Let's talk about what it actually looks like. So imagine that we had a circuit, say a pull up or a pull down, and this is the signal on our input of our pin. And what we would normally expect is that when we press or that our signal is going to be basically, say 0 until we press our button, and then it's going to go up to 5 volts or 1, and then when we let go of the button, it's going to come down, right? And so just to sort of label this a little bit, this would be press here. And then over here, it would be unpressed. We take our finger off the button. Oops, what am I doing here? There we go. And we'll just add some labels here. Okay, that's what we expect it's going to be, right? This is how intuitively you would think that a button would work. Unfortunately, that's not the case. What we expect it to look like and what it actually looks like can be pretty different. So, in reality, if we have our 5 volts and our ground, what it actually looks like when we go to press the switch is it kind of freaks out. That's a technical term for a bit. And then when we let go of it, the same thing kind of happens. It kind of freaks out a bit. And so the technical term for freaking out is bouncing. These are bounces here. And bouncing is not good for a variety of different reasons, which is to say that it becomes a challenge that you have to deal with in software. Because if we consider that there's some magic threshold, say 4 volts and 1 volt or what have you, some magic threshold in there, that the system counts something as either being a 0 or a 1, then we clearly exceed that threshold some of the time and then go back down and are now counted as a 0. And so what this functionally looks like is that when you press the switch, some of the time it seems to rapidly oscillate between 0 and 1 when you press it for some period of time, and then rapidly oscillate between 0 and 1 when you depress it, when you take your finger off of it for some period of time as well. And the period of time changes depending on the switch. Sometimes you're talking microseconds, sometimes you're talking milliseconds, sometimes you're talking maybe even a little bit longer. And so if you write your code in a way that basically looks for button presses, remember your microcontroller is operating at millions of instructions per second. And so it might see each one of these little bounces. And again, I've only drawn it as sort of a cartoon, but there can be lots more than 2, as a unique button press that the user intended to be there. And so what you have to do is you have to brainstorm ways that you take into account this bouncing. And I'm not going to tell you exactly how to do it. You have to figure that out yourself. But basically, to give you a sort of hint here, when you're talking about the button being pressed, once you register a press, for example here, you can sort of have a bit of a, for example, a refractory period or whatnot, where it takes it as pressed and then it can't be re-engaged for some period of time, and vice versa for the other side. Once it's been depressed, then there's some sort of refractory period here. And so the question is, how long is that period, right? And that's something that you're going to have to figure out empirically. So that's debouncing on switches, and we have denouncing here. That should be debouncing. We're not denouncing switches. Down with switches. So that's debouncing switches, and how you, or what it looks like. The behavior is you're going to, it's going to appear as though your software is rapidly registering multiple presses, when in fact you're just giving it a single press. And that's at a conceptual level how we take care of it.